Okay. In this video, I will talk through my analogy of polarization and work through an example. The analogy is as follows. Dough is going through a strainer that has gaps that are equal, so that there's slots that are equal width to the gaps. So when dough is pushed through that strainer, 50% of it is blocked and remains in the strainer. So the dough represents the incoming light waves with various orientations and polarizations. The strainers represent the polarizing filters. The shape and orientation of the holes in the strainer correspond to the direction of allowed electric field oscillations in the polarizing filter. In a real polarizing filter, the parallel conductors will be perpendicular to the allowed electric field orientations. This is one of the limitations of the analogy. So first, I will walk through the analogy with dough. So there are three strainers with equal width slots and gaps, oriented at 0 degrees, 45 degrees, and 90 degrees. So when dough is pushed through the first strainer, only 50% of it makes it through. The other 50% is blocked. The dough is now polarized since there is directionality to it. The dough coming in is unpolarized since there's no directionality to it. So the dough coming through the first filter is coming at you vertically oriented, 0 degrees. After going through the first strainer, it now faces an identical strainer with the same equal width slots and gaps, rotated 45 degrees. When going through the second strainer, another 50% of the dough is blocked since the holes don't line up. The dough that exits this second strainer will act as if it has been rotated by 45 degrees relative to how it exited the first filter. After exiting the second strainer, only 25% of the original dough remains, 50%, 50%. The same thing happens to the third filter. It's rotated by an additional 45 degrees, and the same thing happens, 50% of it is blocked. The dough again acts as if it was rotated by the third strainer, only the dough exiting the third filter is 45 degrees relative to the prior strainer, which is 90 degrees relative to the original strainer, ending at the beginning. The dough that is able to exit all three of these strainers is only 12.5% of the original dough. Next, let's walk through the same example, but with light. In this context, the orientation of, when I say orientation of light, it refers to the orientation of the electric field component of the light. When 50% of the light is blocked/passed, I'm referring to the power of the light specifically. So first, the light entering our system is unpolarized. So in red is the polarization of the light, black is the filter, and blue is the light that has been deconstructed into its two vector components. So first, the light is entering our system is unpolarized. We can deconstruct this to have an equal power component in the vertical direction and the horizontal direction. So when light approaches the first polarizing filter, 50% of its power is blocked. This is because in aggregate, the light has an equal portion of horizontally and vertically oriented light in total. In this case, the filter blocks in the entirety of the horizontal components since the wires are horizontally oriented, which is opposite of what's drawn here on the board. We're showing the direction of the light that is allowed to pass. So when the horizontal and vertical light enter through this filter, when exiting the first filter, all of the light has a vertical electric field component and is oriented at 0 degrees, running up and down this way. We can again deconstruct this vertically oriented light into two components at plus or minus 45 degrees. I'll use this to block the glare so you can see the whole board at this point. So we're deconstructing it into its equal parts. Since these are just vector additions, it's the same light, just deconstructing it through. And let's see. When the light passes through the second filter, 50% of light is blocked at the negative 45 degrees. This light is blocked, and the only light that is allowed is at positive 45 degrees there. Again, we can deconstruct this light into equal vertical and horizontal components, as shown here. And when faced with the third filter, the same thing happens. The vertical is blocked, the horizontal is allowed through. So, the total power of light exiting all three filters is only 12.5% of the power that's entering. 50% is blocked here, 50% is blocked here, 50% is blocked here, for a total of 12.5% that exits. This is consistent with Malus' law, which is as follows. I over I naught equals cosine squared of phi. Where I over I naught is the relative intensity of the light that passes through the polarizing filter, and phi is the angle between the polarizer's allowed orientation and the light's orientation. In the first filter, the light is unpolarized and 50% of it is black. That's just traditionally how when light goes through when unpolarized light goes through a polarizing filter, 50% of it is blocked. Afterwards, the light is oriented at 45 degrees relative to the second filter. And then so cosine squared of 45 is 0.05, so 50% is blocked. The same thing happens between the second and third filter. The filter is oriented 45 degrees relative to the orientation of the light entering, so 50% is blocked. This analogy makes several key aspects of polarization easier to grasp. 1. Selective transmission. Just as only some of the dough passes through the strainer, only light waves with the correct orientation make it through each of the polarizers. Intensity reduction. Since only a portion of the dough is transmitted, the final output is less than the original quantity. Similarly, the intensity of light is reduced after polarization. Double filtering. If you push the dough through 2 strainers with different hole orientations, one vertical, one horizontal, much less or no dough will come through the second. This happens with light and cross polarizers. Well, the polarizers are 90 degrees from each other. Almost all the light is blocked if their axes are perpendicular. And then rotating filter. If you push the dough through a filter with slots oriented at 0 degrees, the dough exiting will have the same orientation. If a second filter is placed at 45 degrees, some of the dough will be blocked, but the dough that exits will be the remaining dough, it will be 45 degrees. Then if a third filter is placed at 90 degrees, the same will happen. Some dough will be blocked, but the dough that exits will be rotated 45 degrees from its previous filter. The 3 filters will block a lot of dough, but the dough that exits will be rotated 90 degrees from the initial filter. While the dough strainer analogy is useful, it is not perfect. Dough is a material substance, while light has energy. Dough that doesn't pass through the strainer remains physically present, whereas light that doesn't pass through a polarizer is typically absorbed by the polarizing filter. By likening the phenomenon to dough being pushed through a strainer, we can make the concept more intuitive and accessible. Though the analogy has its limits, like any analogy, it provides a tactile and visual framework for understanding how polarizing filters operate, selectively transmitting certain orientations of light and filtering out the rest.